What kind of estimates can be made using these statistical inference concepts? Well, a big one is the confidence interval. So we'll have a sample, maybe we'll have multiple samples, but we still won't know what the true population mean or proportion is. But based upon the information that you have obtained from sampling, you can make a ranged estimate of what that proportion would be. So based upon our sample, the average commuter drives somewhere between 75 and 93 miles per week, and we are 95% confident in that estimate. That's a confidence interval. And it will allow you to make decisions with a little bit of information, assuming that that information is going to represent the entirety of the information that you have. So if you're a business, focus group, test your product out on a bunch of different people, and you can assume that the demand from those focus groups is going to be in some way similar to the population's overall demand with a reasonable level of confidence. When you construct a confidence interval for a population mean, one thing you definitely got to ask yourself is, do we know the accepted standard deviation of the population? If you do, if you know sigma, well, then you're going to look for a z-score, and you're going to use this formula that's over here. If you don't, you're going to use S, which is the sample standard deviation that you had. Formula is exactly the same. You're just substituting an S in for your sigma. And the answer that you get in this case is a t-score. And assuming that we have a normal distribution, which you're always going to assume, running these numbers through will give you a reasonable point for each sample, how you think it's going to compare to the actual population mean. With enough samples, you can use that information to make an estimate about what range the actual population mean lies within. So a t-distribution, if you're basing your information on a sample because you don't know the accepted standard deviation of all the information for the population, is going to be a t-distribution, and it looks a lot like a z-distribution. So z is knowing all of the information, a perfectly bell-shaped, symmetric, normal distribution. Well, a t-distribution looks incredibly similar, except the tails are a bit longer because you don't have all the information to work with. You have a smaller overall set of information. There is the chance that you're going to have returns in there that are farther away than from the accepted mean, the accepted average, than they would be if you had more. So a t-distribution looks a ton like a z-distribution. It just goes out wider on the side because you're more likely to have points in there that exist way farther away from what you know to this point to be the average return that you had for your sample. And there's a whole bunch of fancy letters over here and calculations that you can go through to find a value that they call t-critical, which you're going to use in your calculations to figure out what the upper and lower limits are for your level of confidence. I could go through all the math, but again, we are a software-based course in here. Any formula worth its salt is going to have some kind of function that is going to give you this number, so we'll use those instead. The most common confidence level that people use when making these interval estimates is 95%. I don't know why, it's just the way that it's always been. 95% confident is what you want to be before you make a grand statement to somebody else, because there is a chance that you're going to have an error. If you're only 95% confident, you're not 100% confident. So there is a probability that you're going to go through. You're going to run a bunch of samples, and you're going to say, based upon our samples, we believe that the population's overall proportion, or mean, is between these two numbers. And you're going to keep continuing to gather data, and if you do this long enough, you will actually know what the population's mean or proportion is. Alpha is the chance, in this case, that the accepted population mean, once you have all of the information, doesn't actually fit inside your interval. So with 95% confidence level, you're saying you're 95% confident that it is between these two, but there is a chance that we're going to have an error that once we get more information, we're going to find out that the estimate is wrong, and that's going to be our alpha. And the way that this works its way into our math is through this t critical value that we're going to use later. It is alpha divided by 2, and then degrees of freedom is expressed as your sample size minus 1. Again, Any software is going to have a function where you can just go and grab this number anywhere. But essentially what it is that your probability of error split in half and adjusted for the size of your sample. If you're looking for a proportion, here's our formula to find our bounds of our confidence interval. Yeah, that looks like fun. It is p hat, p bar if you will, plus or minus z critical, our accepted chance of our error, divided by 2, over the standard error for a proportion. Again, that's a lot of math to run through over here. For this value, instead of doing a bunch of crazy calculations, we can just snag that again with our software. So, a lot of formulas going on there without a lot of examples. Let's have one of those. In a survey of 25 firms, 7 of them have noted that they've experienced a cyber attack in the past 6 months. This is definitely a growing problem all over the place. Hackers trying to get in for information about all sorts of stuff. Your customers, your clientele, the vendors that you work with. We went out and polled people in our area, and in the last 6 months, out of that 25, a certain amount of them told us that they experienced a cyber attack. 7. We're going to construct an interval that we're 90% confident that if we polled every single firm in this area that we're looking for and found the true population proportion of every firm that exists, that the average number would be between in the last 6 months. So, P bar, X divided by N, the number of returns that you got that met the criteria. Our criteria was, did you experience a cyber attack? This is the number of people that said yes. N, the sample size. So 7 out of the 25 said that yes, they experienced a cyber attack. That's the proportion of our sample that met the criteria. Or if you will, 28% of our sample met the criteria. We're going to construct a 90% confidence interval. Well, what we're going to know here then is that alpha, our margin for error, is going to be 10%. There's a 10% chance, if we go with this level of confidence, that we're going to make an estimate on, if we polled every firm instead of 25, what proportion had a cyber attack within the last 6 months. And we're going to, those 10%, that when we get all the information, that might not actually be the case. Divided by 2 to get 0.05. Z critical for a 90% confidence interval is going to come out to 1.645. Maybe some of you have taken a stats class and you've seen these numbers enough that they get regular. People typically look for set intervals of confidence, 90, 95, 99, etc. And your Z critical will come out to be a fairly regular number. Well, the math for all of this, that again a software program will use for you, is going to come up with a number of 1.645. So now we have enough information to fill out our formula. We take our population, or we take our sample proportion that we had here, 0.28, plus or minus our Z critical of 1.645, and then we multiply that by our standard error, and for proportion it is your P bar times the complement of P bar over the sample size. So all this is a whole lot of math to do to come up with this on the bottom. It's going to come out with 2 returns because it's plus or minus. The return that minuses is going to be 13.2%. The return that pluses is going to be 42.8%. And what this means is that based upon this information that we have here and the size of the sample that we got the information from, we can be 90% confident that after we get information from every single firm that exists in the sector within the United States, that the number of firms that have experienced a cyber attack within the last 6 months is going to be somewhere between 13.2% and 42.8%.